Okay, so we have 7 chapters only for engineering mathematics. We already covered 2 chapters in week 2. You have 14 weeks in one semester. So we should, according to our speed, chapter 2 should be covered week 4, which is next week. Only we finish. But we move a bit faster. So I will slow down from here. Then we see if you can cover chapter 4 next week, then your test 1 will be covered 1 to 4. If not, then we only cover chapter 1, 2, 3 in test 1. Test 2 will be 4, 5, 6, 7. Okay, then your final exam, you'll cover every topic. Okay. Okay, so in chapter 3, we learn complex number. Complex number means something power something. Then you add them, you multiply them, you subtract them, and so. So today we only maybe we cover up to here lah, up to here, and we see. Then we continue tomorrow. Okay, why we learn complex number? So complex number learn in electromagnetic, telecommunication, and also AC circuit. So in your circuit design, you will see complex number. Okay, so I think some of you, I think in the circuit design, you start to see some equation already, right? And also, you will see this one in your static class later or dynamic class later. In your year second semester, this more on stratus and frequency vibration, right? Then electromagnetic wave, this one. If you take your, this one more on avionics, the antenna, all these things. Okay, so what is important is when you learn mathematics, it's not just formula. As long as you understand what is the application, why you learn it is more important. Okay, so you will learn Laplace transform in control theory. This one in your final year, right? Control theory means you put in amplifier, and then something happened to the motor and so on. So this one in the year 3, maybe year 3 in your avionics class, you will see something like this. Okay, Laplace transform and all this. So also killer subject for Laplace transform. One of the two. So another one is fluid dynamics. This one in the aerodynamics chapter module. You will look at the boundary layers of the wing, laminar flow, turbulent flow, and all this. This one is important in your aircraft design or aerodynamic design. Okay, so this one later, you will see something like this. So you already seen something like this in your circuit design, either not yet or you already done. So you see some circuit like this in complex number. So complex number means you have an imaginary numbers, symbol I and J, I, J, K. In X direction, Y direction, Z direction, I, J, K. So this is on the electrical side because we are unable to imagine the current in the imaginary plane. Another one is on your dynamic class. This one is in your second sem, if not mistaken, second sem or third sem. This one is on the analysis on the movement of piston. So you need to calculate at a certain time t equal to 2 seconds, where does it go? Where there's a position. So you need to use complex number. Yes. Yes, this one dynamic. You have static and dynamic. Dynamic means movement of something. So you will see this one. Okay, so there are two types of complex number. One is on polar format, which is r and theta, which is we deal with the magnitude and also the angle. We play with, it's always in the circle movement, polar form. Polar form means you are seeing the R, the radius or the magnitude, and also the angle. And in the polar, we always use pi. Pi means 0 degree, 0 pi. 90 degree is half pi. 180 is 1 pi, and so on. So if you're in polar, we always deal with pi number. Okay, so you will see z equal to r something, s something. Later we will explain. But today we just see a picture, just a general view. What is the general form of complex number? You have two set number. So in exam, you need to switch between polar and Cartesian. Cartesian means on the graph paper, the normal x-axis and y-axis. But for this chapter, as long as it's go up vertical, we use J. Go to the x-axis is I, and K is Z lah. So, but anyway, it's just Cartesian means on the graph paper, X, Y, Z. If polar form means you need to change X, Y, Z into a degree. Okay. All right. Then conversation between Cartesian and polar is the conversion, trigonometry. You know trigonometry? Hypotenuse, and so on. Cos, sine, tangent, all this you have to recall back. Okay, so conversion from Cartesian, you use trigonometry and then go into polar. Same with polar, go to Cartesian, go to trigonometry, then go to Cartesian. This diagram explain the whole chapter already. If you understand this diagram, all the notes are on this diagram. Okay, now before we go, another diagram that you see in this module or in chapter 3 is called Argand diagram. Okay, your test 1, test 2, and also final exam, you need to present the answer on the Argand diagram. Argand diagram means you have y-axis and x-axis. X-axis is called real axis, mean real number. And the y-axis, we call it imaginary axis. So when the question asks you to present your answer in Argand diagram, this is only in Cartesian format. Okay, Argand diagram is only Cartesian answer. You cannot use Argand in polar. No, cannot. Because the unit is different. Polar is pi. Argand is only real and imaginary. Okay, so your shorthand or short form, you can use RE bracket X, Y, Z or something. And then the imaginary, you can use IM, then bracket the axis, usually Z and something. Okay. So Argand diagram, it just give you the axis, the real axis and imaginary axis. So the format that you will see later, you will get a real number and imaginary number, A plus BI. I means in static or dynamic class, I means x direction, imaginary x direction. Okay, Z to the Y, Z, K to the Z. Okay. And for this module, for this chapter, we will interchange the I and J. Means sometimes you will see I use J to represent imaginary axis. Because this module, the X, Y, Z axis doesn't matter. We only deal with two-dimensional imaginary axis. In static and dynamic, you go into three-dimensional. So that's why from there, you need to be careful on your IJK. But for this mathematics, engineering, mathematics 1, we only deal with 2D. So it doesn't matter you use I, J, or K. You need to follow the question. If you in the question you see I, you need to answer in I. If the question you see J, you answer in J, and so on. Okay, so this is the difference between module and modular answer. All right. And for your circuit design, if we rarely use I in the answer for circuit design, because I also represent current in ampere. So we don't want to confuse the I current in electrical. So when you see electric diagram, usually we will change I into J to represent imaginary axis. This is the some notes lah. Okay, but if you see I, small j, small k, they are all imaginary axis in chapter 3. Okay, so quadratic equation, you should know how to solve this, the root of the solution for equation, right? X equal to minus b, right? Minus b square plus minus that one. This one we assume you already know. So we assume you already know lah. So we work with Cartesian complex number. So let's say you have the x-axis equation, quadratic equation, x squared plus 2x plus 5. If you want to solve the root, you just plug in the ABC number. Okay. And then you solve it. Okay. Now, reminder for the square root. Every time you use square root, there are two numbers, positive and negative. So you need to keep reminding when you do mathematics or in static or dynamic class or in your electric current yang deal with the square root. Sometimes you only answer half. So if the final answer is 2 marks, you might miss the negative side. You always give positive answer. So for this module, you need to remember you always have, if you see the square root, always have a positive answer and negative number. So like this. Okay. So if like this, you square root this one. When you square root, like for example, this one, this example, you will get negative 16. So negative 16, we start to apply imaginary number, which is the I. Or I square equal to negative 1. But for a faster calculation, we always remember I equal to square root minus 1. Okay, so when you go into static or dynamic, you will see I square and something when you deal with matrix later, matrix calculation. But in this module, we won't go to that higher level yet because this is entry mathematics 1. Okay, so we replace I equal to square root minus 1. We can change this equation, the square root minus 1 equal to minus 2 plus minus 16i. Right, we can write something like this. So this square root 16, we can write at square root right as square root 16i. So you get 4i. Yeah. So you replace this one inside here. So you have 2 root with the imaginary number. Okay. So in the real case, why we need this one? Because sometimes we cannot go inside the wall, but the electromagnetic wave can go through the wall, right? So that's why you use IJK. Okay. So the final answer, remember, when you have a square root, they always have a plus minus sign. This is sufficient. If you Rajin, you can break into 2 answers lah. But if you write like this, also correct. Okay. If you write like 2 minus 1 plus 2i, comma minus 1 minus 2i also correct. Means you can break into 2 answers. But if you write like this, also correct. Okay. So this is where the imaginary numbers come into place lah, when you have a square root of negative something. Okay. Okay. So again, square root negative 1 is not a real number. In mathematics, it exists, but in the real dimension, it doesn't exist. So these two answer, 2 minus a. Oh, sorry. This is step number 2. It just second note. So -1 plus 2i and -1 minus 2i, they are called complex number. So sometimes the question will mention, put your answer in complex number. It means that I want you to write this kind of format. Or in other way is just want to see you to write in I. And we want to see you write this one in one of your steps. I equal to square root -1. This carry 1 mark always. General equation or special remark, even you don't know how to solve, you write I equal to square root -1, you get 1 mark. Or you write I square equal to -1, also get 1 mark. For chapter 3 question. Okay. All right. So in general equation, you will see A plus IB or A plus BI also correct. Yeah, I mean the way how you write it is also correct one. It depends on the preference of publisher. So some author, they like to write imaginary in front. Some like to write after. So for this module, I recommend to write something like this. Means the number in front, the imaginary number. But it's up to your preference. If you write I in front, also correct. Okay, so if you're able to write A plus IB, they are called Cartesian complex number. The way you write it is also important. If the question asks you to write in polar complex number, then the answer is not this presentation. It's another kind of presentation already. Okay, this is some refreshment cost for some of you. Okay, the rest you read. I already explained. We sometimes use J because you are dealing with electric current, just not to confuse the calculation. Right. So I just some extra notes mean you have IJK depends on axis as you move on. Okay, as you move on to your core subject in aerospace. Okay, let's solve this one. Right. Try to solve this one by using the quadratic equation. X squared plus 4 equals 0. The root is what? Justin not here. Justin Chan Kai Wen not here. Okay. Huh? Lesson? Oh. If you read the reason, only 3 reasons we accept already. MC, if you sick, if you don't sick also, sorry, I'm recording, so I cannot say. So only 3 reasons. So one is medical reason. Go and find doctor, give MC. Second reason is the pass away of your family members. Means we want to see the death certificate. So the date of the certificate, date of that person must be on the day of your class. It cannot by your class today, but the death is next week. Cannot. Means we cannot predict somebody death next week. Right? Cannot predict. Okay. The third reason is you represent university for state competition or anything. Right? Okay. So we review the answer for this one. So you can use the b square something b minus b, but this is a big direct question. So you square it, but you got the negative. So you need to write I equal to square root negative 1. So basically this is 2i. Okay, plus minus 2i. Okay, if you only write 2i, you only get half of the answer. Normally in mathematics, the general equation 1 mark, step 1 mark, final answer 2 mark. Usually like that, with the correct unit sometime. Okay. So this is just a remark. You can write I2 or 2i. Okay. So remember this this one must write in your answer. I equal to square root minus 1 or I2 equal to minus 1. This one is important, these steps. Must write in all your test 1, test 2, and final exam question. This one carry 3 marks. This one carry 3 marks. Okay, next question. Okay. Next question. This one you need to use the minus b question. X equal to minus b plus minus square root b square minus 4ac divided by 2a. And some calculator, they already have this formula. You just need to find the solve button. You press in the formula. You press the solve button, it will solve for you. For some calculator, they're not able to tell you imaginary lah. Some can. Some will give you I symbol. Okay. Okay, your answer should be the one that you see on the screen here. All right. So you can put your answer in the fraction format or in the decimal format. Means in the digit format. If you put a digit, correct to 3 decimal place. Yeah. So how we mark your paper? First, we see general equation. If this one need to use x square equal to something, you need to write this one, x equal to minus 3 plus minus square root b square minus 4ac divided by 2a. You need to write this one. Where a, b, c, this one is option. Whether you can write or you forget to write also, never mind. As long as you write general equation, then you follow by the correct substitution. Then I know already what is b, what is a. Then you solve. Important to write I equal to square root minus 1 for chapter 3 question. Then you continue to solve and give the final answer. This one? This one? This one is divide by 3 divided by 4, 3 divided by 4. Yes. You understand this formula, right? Okay. Okay. Means this one, the whole on the top here divided by 4. Yeah. Okay, so if you plot graph, if you plot graph of quadratic equation, you see, you know that in chapter 3, your y-axis is imaginary, your x-axis is real number. It never cross x-axis. There's no intersection of x-axis. Okay. So this is where you get the imaginary lah. So it will cross at somewhere here. Yes. Yeah. So this one you go home. You don't do as long as you understand what is happening. So this one, J means I. So I multiplied 3 times is what? I square is what? I square is -1. So -1 multiply square root of -1. So -1. So this one actually can calculate very fast. Okay. So I show you the first one. So you can break into two for more easier lah. But I won't ask this kind of question in test lah. Too easy for you guys. Okay. So you can just simplify j square equal to -1 multiply j. So you know that j is square root -1. You put your answer in. You don't need to give me there's no more further simpler answer. Put in imaginary unit. Okay. So J4 is -1 -1, 1. Okay. Okay. So you need to show these steps. Then you can write j square multiply j square equal 1. Okay. But don't skip these steps. Don't skip this kind of step, because this one is your core step, means you explain what actually you do. Because you already write j equal to square root -1 already. So this you can skip this one. This -1 equal this one. You already write in the one corner of your answer already. So in this module, general equation is very important. Don't skip general equation. Okay, 23 you can break into 22 minus multiply j. Okay, 22 also you can further break into j square bracket 11. This steps is actually in chapter 4. This here to here is actually in chapter 4, but we jump step a bit. Okay, so if you learn in chapter 4 later, bracket and multiply with exponential actually is the multiply. 2 multiply equal to 22. So of course you have other creative way also correct, as long as you use the imaginary number. Okay. So put in minus j. So -4 divided by j. I think something wrong with my answer. It should be okay. This is the wrong answer. So basically, it should be j -8. It's because it's 1/9. Okay, it should be -8. Okay, then you solve lah. Okay, D is the wrong answer. D is wrong answer. It should not be this answer. D1 on my slide is wrong answer. It's only correct when we move the J to the top. But if this question should not be this answer. Okay. Okay. See, sometimes okay. So what we do is we break into another steps. I explain why suddenly it can be J. So if we analysis J power 9 equal to J power 8 multiply J, it will be J. j power 9 equal to 8 multiply j. Then you break 2 and 4. Again, 2 bracket 4, this one is chapter 4 content. At the moment, just accept it first. Okay, 2j4, j2 is -1, -1 power 4 is 1. So later, this is what we get, j. Okay, so -4 divided by j. This also in chapter 4 content. If you have an imaginary number, we want to remove it in the denominator. How we do? We use conjugate. There's a word called conjugate, means if you have j, conjugate is a negative of that complex number. Conjugate means you multiply with the conjugate, because minus j divided by minus j actually is 1. So sometimes this blue color box is used in mathematics. We create something out of the space just to remove something. In this case, we remove the denominator. No, if we j by j, we actually multiply. We already changed the magnitude of that complex number already. Mean this one you do not change anything on the subject. So what we do is, for complex number, we will multiply the conjugate number like this. So yes, here should have j lah. It should have j. Okay, j is missing lah. J is missing actually. J is missing. Then at the end you will get 4j. Okay, so something not covered in chapter 3 is the bracket multiply something. 2 bracket multiply 4 is multiplication of exponential. And to remove conjugate, to remove complex number at the denominator, we'll use conjugate number. Means the negative of that the denominator. Yeah, it's called conjugate lah. Conjugate number. Yeah. Okay. So this is a practical practice exercise. You go home and do lah. Go and do. It might appear in your assignment, which is I think 15 marks. That 15 marks. Okay. Very high chances, or I will just give you the new. No, not necessary to complete all. This is just for your exercise only. Okay. But very high chance I will just copy this one and paste in your assignment, submit. Okay. So this is your homework lah. Okay. If you Rajin, you do. If you know, you understand already, it's okay. Important you understand how you solve it. Right. Okay. So these are the answers. Okay, we go into Argand diagram. Okay, Argand diagram in this on my slide, I will always just straight away show you the diagram. But during your test, you need to draw real axis and imaginary axis. Okay, so you can write RE at x-axis and also IM in y-axis. Okay, draw these two, and then use your ruler to separate the axis. Okay, same with the y, but remember to write the imaginary unit. In this case, we use j. You use I also, correct? J, because in engineering, y-axis is always j lah. We just straight away use j. Okay, if you use I also, okay, no problem. Okay, so we can present using Argand diagram, right? So the rest you read. So let's say point A. When you calculate your answer is 3 plus J2. You need to draw this answer on the Argand diagram. How you do? The front is x-axis. The front is x-axis. The 2 is y-axis. So you go and find 3 and then go up 2. So then you mark, then you draw an arrow. This is the direction of origin to A. Okay, this is called vector in static and dynamic class. So it's called vector. Okay. Yeah. So B and C, you should be able to understand also. Huh? Okay, so on the Argand diagram, there are 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. In Argand diagram, direction is anti-clockwise. Positive direction is anti-clockwise, following the polar plot. Is anti-clockwise, huh? So quadrant 1, quadrant 2, quadrant 3, quadrant 4. So in later chapter or in later section, you need to tell me where is the complex number fall into. Either it's quadrant 1, quadrant 2, quadrant 3, quadrant 4. In later, maybe tomorrow you will see. Okay. Any question on this one? Quite direct, huh? Okay, I think we stop here. Tomorrow we do addition and subtraction. Huh? We move to pass. So today your homework is this one. The homework. You think like okay. So we stop our class here. See you guys tomorrow. H106. Okay.